Good morning one and all. Today I am going to teach another problem in windowing method. The question is design an FAR digital filter to approximate an ideal low pass filter with a pass band gain of unity, cutoff frequency of 850 Hz and working at a sampling frequency of Fs equal to 5000 Hz. The length of the impulse response should be 5. Use rectangular window. Here first we have to write the given data. Okay, the given data is it is a ideal low pass filter, that is e power minus j omega tau value is 1. Okay, in hd of e power minus, otherwise hd of e power minus j omega value is always 1 for the given limit, that is it is of a low pass filter. So we have minus omega c to plus omega c. Okay, the limit will be from minus omega c to plus omega c. In that limit, the value of hd of e power j omega is 1. The desired frequency response is always equal to 1. That is, it is given ideal low pass filter. So it is equal to 1. Then they have given the cutoff frequency, sampling frequency. So omega c is equal to, we know the formula omega c equal to 2 pi fc divided by fs. So in fc sampling, that is cutoff frequency is 850 Hz and sampling frequency is 5000 Hz. So 2 pi into 850 divided by 5000, that is you will get 1.068 into radians per second. That is, the unit is radians per second. Okay. Next you have to write the limit. So in the place of f, you can, our limit is from minus omega to plus omega, otherwise minus omega c to plus omega c, the cutoff frequency. Our limit is from minus omega c to plus omega c, so that we have represented as in modulus. This also we can take, modulus means always we have to take both the positive and negative values. So you will take the limit from minus 1.068 to plus 1.068. Okay, so we can write the formula as hd of n is equal to 1 by 2 pi into integral minus pi to pi hd of e power j omega into e power j omega n into d omega, that you can write it as 1 by 2 pi into integral minus, we know that the limit is minus 1.068, so we have to take modulus is there. That is, always low pass filter is from minus omega c to plus omega c. So you can take it as minus 1.068 to plus 1.068 into, that is e power j omega minus e power minus j omega tau is 1. So e power j omega n to d omega. Then you can differentiate and you can substitute the limit value. Okay, so you will get 1 by 2 pi n. When you are substituting the limit values, you can take the form in the sine form. Okay, you will get it as sine 1.068 into n divided by pi n. Okay, now when you put for n is equal to 0, you will get in indeterminate form. So for n is equal to 0, we have to use L'Hospital rule. Okay, so when n is equal to 0, use L'Hospital rule. So for n is equal to 0, can use L'Hospital rule, that is differentiate the numerator and denominator with respect to n. So you will get cos 1.068 into n divided by pi. Then you substitute the value of n as 0. So you will get 1.068 divided by pi, that is 0.3400. Okay. Now in the question they are asked to use rectangular window. So rectangular window for both causal filter and non-causal filter, we have the same function. So that is no problem. So here no problem whether it is causal or non-causal, that is no problem. So you can write that function as, we know that function w of n is equal to 1 for modulus of n less than or equal to m minus 1 divided by 2. Here it is there, modulus is there. So we have to take both the minus and negative and positive values. So we can take it as minus m minus 1 divided by 2 to plus m minus 1 divided by 2. So m minus 1 divided by 2 means here the value of length of the impulse response is 5. So 5 minus 1 divided by 2, that is 4 divided by 2, that is 2. Okay. So we have to take the values from minus 2 to plus 2. So we have to take only the values from minus 2 to plus 2. That is, we have to find ht of minus 1, ht of plus 1, ht of 0, that's all. Okay. And ht of 2 and ht of minus 2. Here we need the w of n is always equal to 1 for the limit from minus 2 to plus 2. So you don't need to find, simply you can find hd of n and you can put that as h of n because it is 1. So 1 into this value will get the same value. Okay. 1 into 0.34 is 0.34 only. So that value itself you can simply write it as h of 0, h of 1, h of 2. Okay. So h of 0 is, we have already found hd of 0 is 0.34. So h of 0 is hd of 0 into w of 0. W of 0 is 1. Okay. So h of 0 is 0.34. Similarly, h of 0 is hd of 0 into w of 0. W of 0 value is 1. So 0.34 into 1 is 0.34. Similarly, h of 1 is 0.2789. That is, hd of 1 value is 0.2789 and hd of minus 1 value also 0.2789 into w of it. That value is always equal to 1. So that h of 1 that is equal to h of minus 1, that is also equal to 0.2789. Similarly, h of 2 and h of minus 2 value is also 0.1344. So we have find the filter coefficient value. That's all. Thank you.